A very good morning to all. I, Priyanka Trikha, welcome you all in the last day of FDP on blockchain technology and its applications. I welcome you all on the behalf of SKIT family. Our today's eminent speaker is Dr. Ajay Kuteta, Professor Purnima College of Engineering, Jaipur. He is going to take the session on Ethereum smart contracts using Solidity. Over to you, sir.
Thank you, Priyanka, for introducing me and
Thank you,
welcome
sir.
all. Yeah,
Sir, I think you have to again share your PPT. Your PPT is not visible.
yes. I think now it's visible.
Yes, sir, it's visible. Thank you, sir.
Okay, okay, thank you. And good morning, all. So today we have a session on Ethereum smart contracts using Solidity. So Solidity is the programming language where generally we deploy uh, the smart contracts of Ethereum. So I assume that you know all the fundamentals of the blockchain because it's a very good FDP and very you can say the speakers are there. I just seen the name of the speakers and the topics are very relevant. And today is the last day, and during last 5 days, I assume that everybody is now knows the fundamentals of blockchain and even that how we can use the blockchain in the different areas of to the society. It may be in education sector, it may be health sector, and financial sector is of course a very big scope for the blockchain. So today we start to learn. Today we are going to learn that how we can write the smart contracts using the Solidity. So I will try to cover all the basic concept in a very fast way. If you have any question, then you can write in chat box. I'm timely. I will try to reply. So my focus is that how we can write the smart contracts using the Solidity and how we can run the smart contracts. I will try to show you the output of the smart contracts using the Linux IDE web browser also. So let's say fast brief introduction regarding the blockchain, the blockchain technology, then how we can mine the blockchain, and Ethereum introduction with the technology. Then we cover the Solidity and some demo on Remix ID that how we can run the code of smart contracts using the Solidity, and then we have the conclusion. So first the blockchain. So as you know that the blockchain is a distributed, decentralized peer-to-peer network that provide the immutability, privacy, security, and transparency. So you know the meaning of privacy, security. The immutability means the reverse process is not possible. Once you have created the block in the blockchain, then you cannot change the content of the that node. So how it's possible or how it is, I will try to show that how it's mutable using some demo projects. This picture basically describes the blockchain technology. So basically, when somebody is requested that my transaction is there and try to include the transaction into the block, then his request is broadcast to a peer-to-peer network of computers that is called nodes, and then the network validates the transaction using some blockchain protocols and algorithms. So after verification, the transaction is combined with other to create a block because a block may have hundreds of transactions of the data for the ledger, and then new block is added to the blockchain in a way that they cannot be changed. It's not reversible, and then the transaction is completed, and you can see you can check their transaction within the blockchain. Why blockchain is required? What is the need of blockchain in today's world? The blockchain is basically the technology which is the centralized, which is not the centralized, the decentralized technology. There is no single owner is there who can control the blockchain. So no third party is involved. It's unalterable copied only, And the real-time tracking is not possible. Security is there, no single point of failure is there, and basically it's reduce the cost and the transparency is there. Now the miners, I know that you all know about how we can mine the nodes, and the person or the system who is mining, that is called miners. So for a block to be accepted by the blockchain, it need to be mined. So before you enter that your node should be the part of the blockchain, it should be mined. To mine a block, miners need to find an extremely rare solution to a cryptography puzzles. Cryptography puzzles means, suppose later we try to do this using some projects. Suppose you want to say that I want to suppose I have a message hello world. Now to include that smart contract, I have to create the hash code using some SHA algorithm of registering hello world. Then after the SHA algorithm, we have a hash value of that string. So when we apply the algorithm, a nonsense value is there, that is the random value. So puzzle is that the algorithm distribute that particular hash code with the data, and the question is that try to find out the nonsense value which create that particular hash. So the person or the node who find out that value first is winner, and that node is included in the blockchain. So if a mined block is accepted by the blockchain, the miner receives a reward in terms of the bitcoins additionally to the transaction fees in the terms of gas. So the mining process is also referred to as proof of work (POW) and the proof of stake. These are two consensus algorithms through which we can validate the transaction and include the node into the blockchain. The transactions are grouped in a block, and blocks are applied and appended to the blockchain. In order to create a chain of blocks, each new block uses the previous block hash as a part of its data. So in this way, it increases the security of that particular node. To create a new block, a miner select a set of transactions as the previous block hash value and mine the block in a similar fashion. So I will try to demonstrate the process later on. This is basically maplet tree, that how the security is there in terms of the blockchain. That's why we are saying that security is very good in the blockchain, and even many you can say the groups are there, hacker groups are there who try to reach the security of the blockchain, but those all are unsuccessful till date. No attacks is found in the case of the blockchain. So basically we have a lot of transactions. So in a block, the lot of transactions are there. Each transaction we convert using the hash value using the SHA algorithm. So see is the bottom part here. The transaction 100, transaction number 101, transaction 102, transaction 103. So to make a block, each transaction is encrypted using the SHA algorithm that produce the hash code. So each transaction we have the different hash code, and then we match this hash code in the form of tree. So hash code of transaction 100 is hash 100, transaction hash code of transaction 101 is hash 101, and then we again apply the SHA algorithm and to produce the hash of including data of 100 and 101 hash code. And similar fashion, we have more hash code from hash 102 and 103. Again apply some algorithm, and after certain steps, we have the hash code of the root. So that root hash code is included into the blocks. So you can see that one hash code is you can say just impossible to break and to find out what is the actual data. So many hash codes are there. So many times we are trying to produce the hash with the previous hash. So it's just impossible to break the security in the case of blocks. Okay. So these are transactions are there. Each transaction secured with some hash code. That hash code again merged with the certain other transaction hash code, and in this way we are getting the hash code of the root, and that tree is called the maplet tree. So these transactions are there. This previous hash is the hash of the previous node, and then is nonce is a random number which is used to the algorithm of SHA to produce the hash, and then this particular hash value of this node is taken by the next node as a data, then it will take the three inputs. One is the nodes is there, previous hash value is there, and this root hash value is also there for each transaction, and some input data is there. So in this way, they create a chain of the blocks, and then finally they will add this blocks into the blockchain. So if you see that how it's working, so you can online check. There is superdatascience.com blockchain hash is there. The demo projects is there. So I will try to show you that how these values are generated. Yeah. So it's a data is there, so you can enter, and suppose you want to encrypt that my name is Ajay. So simple using SHA algorithm, SHA-256 hash algorithm, it generates the hash code. Okay. So this data is there, and corresponding hash value is this. Okay. So how we can create the block? So there is a mesh tag is the called block. So here, this is the block number 1, and similarly, we have suppose data is Ajay. Let's mine it. Okay, once you mine it, this hash code is generated. Okay, so when you mine it and when you create the blockchain, so when blockchain is there, so there are n number of blocks are there in the blockchain. So in this project, we have the 5 blocks. Okay, block number 1, block number 2, block number 3, block number 4, up to the 5. So how they are connected? So block number 1 is there, and this random number is there, 11316. You can use any random number here, but there is another algorithm which is used to generate this value. So suppose the first value data is my name Ajay. Okay, so when you mine it, so to see the hash value of the previous node is 000 because it is the first node in the in our blockchain. So that is called the Genesis node. In the case of Genesis node, you can say like the root node is there, in which the previous hash value of the previous node is 0. Okay, so this hash value is
Excuse me, sir.
Yes.
Sir, your screen is not visible.
1 minute. 1 minute. I think it is visible now.
Yes, sir. Thank you, sir.
Yeah. So let me show again. The first, there is a project is there, and the link is there, tools.superdatascience.com/blockchain/hash. So it's a basically a simple SHA algorithm through which you can generate the hash for your data, for your transaction. So suppose my transaction is the string is Ajay. Okay, so corresponding hash value is this. Okay, so each transaction you can generate the hash value with the SHA-256 algorithm. Then how we can create the block? So simply the block number 1 is there, some random number is there, and then the data is suppose again I have entered the Ajay. When you mine it, create the final hash code. So that hash code is 000. When we use the blockchain, the case of blockchain means the n number of blocks are there, and each block are connected by their hash value, final hash value. So in this case, we have the suppose in our case we have the 5 nodes. Node number 1 to node number 5 is to form a blockchain of 5 nodes. So block number 1 is there, some random number is there, some suppose data is there. So I am entering the data Ajay. So if you mine it, yeah. So see that previous hash value is 000 because it is the first node of my blockchain, and the first node of blockchain is called the Genesis node. You can assume that like in tree the root node is there, which predecessor is not a node there. Okay, the node which has no predecessor is called root node. Similarly, the node which has no predecessor node is called Genesis node, the first node of the blockchain. So the previous hash code is 000. And this next value of the hash code for this data Ajay plus previous hash code plus this value. Now in case of blockchain, the block number 2, suppose again I have entered the data, suppose string my name is It may anything, it may any transaction also. So when we mine it, see the hash code of previous value, na 00042B. So here the 0042B is there. So it store that particular previous hash value, and the hash value of the current node is 0081 and so on. So similarly, when we use the block number 3, we can similarly use the block number 5 and block number 4 also. Okay, so you can see that the hash value of this node is used by this particular the next node. Okay, so in this way we can create the blockchain of several nodes. In case of distributed blockchains are there, so we have certain peers are there. So peer A is there. If you scroll down, then peer B is there, and peer C is there. So each peer they can use the same concept that enter some data, mine it, create the block number 2, enter some transaction, mine it using the hash value of the previous node. Similarly, the block number 3, the value that is there, some transaction value is there, and you can mine. Okay, so in this way we can create our own blockchain using some concept which we discuss in next slides. Okay, so I think that concept of blockchain is clear to all of you, that how we can generate the different nodes in the blockchain and how we can provide security using the SHA algorithm. Okay, so yeah, so this is the rule of miners, that's how we can create the node. Okay, so there are certain algorithms also through which we can mine the node and we can validate the node. There are two types of consensus algorithms are there. One is called the POW, called the proof of work, and second is called proof of stake, POS. So later on we discuss on short also at how these algorithms are working. So this is the Merkle tree, which is generally demonstrate how we can create the tree of the different hash values of all the transaction in a node. In a node, there are several blocks. In any block, there are thousands of transactions. Okay, which transaction we will include in the block, it totally depends upon the miner. It's his choice. That's why we pay some Bitcoin or some gas values there, so that they should include your transaction into the blocks. Okay, so this is the link of that particular blockchain project. You can also see using some particular values and how we can create the blockchain, how we can create the hash code. Okay, now there are different types of blockchain platforms. We are not going deep into the blockchain because I assume that in the previous session you know all the fundamentals and advanced part of the blockchain. So now the different types of blockchain platforms are there, like Bitcoin is there, Ethereum is there, IBM blockchain is there, Multichain is there, Ripple is there, IP, Corda is there, BigChainDB is there, and many more platforms are available in which you can start your projects in the area of the blockchain. You can create your smart contract, you can create your node, you can learn that how we can create a distributed blockchain. Okay, so out of these, I will take only the Ethereum platform for the blockchain projects in today's session. So what is the Ethereum? So basically, Ethereum introduced in the year of 2013, but for commercial purpose, they launched in the year of 15 to 16. Okay, so Ethereum is an open source blockchain-based platform that essentially enables hundreds of decentralized cryptocurrency and projects to build and deploy without having to build their own blockchains. On Ethereum, you can write code that control the money and build application accessible anywhere in the world through internet. And originally, the paper was published by Vitalik Buterin and the founder of this Ethereum concept. And commercially, they launched in 15. And but more clearly, you can say they successfully implemented in the year of 16. The unit of the Ethereum is V, the one WEI, that is the smallest unit of Ether. It equivalent to the 10 to the power minus is not 18, is I think yeah, is minus 18 Ether, and one Satoshi, that is the smallest unit of Bitcoin, is equivalent to 10 to the power minus 8 of Bitcoin. Okay, so this is the introduction of Ethereum. So how we can create the Ethereum node, how we can create the Ethereum smart contract. So Ethereum node to Ethereum node is similar to the Bitcoin, the blockchain node we have. And Ethereum node is any device that is running the Ethereum protocol, that is the blockchain protocol, running on desktop and laptops. Development for mobile is going on, but recently some PhD student group in the Stanford University, they announced that they have launched a Pi network, Pi node that is using the mobile mining. It means they are running the Ethereum protocol using the mobile phones. Okay, but that is not available for the commercial purpose. It's still it is in the development phase. So still we are running the node only using the desktop and laptops. By running an Ethereum node, we can connect to other nodes in the network, have directly access to the blockchain, and do mine blocks, send transaction, and deploy our smart contracts. Nodes are written in the generally in Go, Ethereum, and Get language. Even C++ and Python is also capable to in which you can write your cryptocurrency code. Even I have seen some projects of Bitcoins in our department also. Questions are working using Python. Cryptocurrency you can develop in Python also. So download the entire, suppose Ethereum you want to download the entire blockchain. So go to the site that is the get.ethereum.org/download. So here you can download the Get software that is essential for create the node in the Ethereum. So I will show you that how we can download it and how we can download the entire Ethereum blockchain into your PC. So just you can go to the site of getgtca.ethereum.org. So you will find some version for Linux, some version for Mac OS, some version for Windows, and the open source is also there. So just scroll down and installer for 64-bit is, yeah, I think for Windows you can download this installer. Okay, 64-bit installer is there, and this is the link through which you can download the Get version 1.9.25, and when you will run it, it will store into the program files of your computer. And like I have already downloaded it, and when you install this particular file, it will be stored into the program file. See where it is. Yeah, it is a folder of GETH. Okay, so it is basically stored all the, you can see how we can connect with the blockchain, all the server configuration, the node configuration, everything you will get this. Okay, so after downloading this Get from this particular site, that is the get.ethereum.org, you just open your command prompt and run that command of, first go to the program file. Go to the folder of this gets, and then write the command of get GETH. Just write it and press enter. It will start to download the entire blockchain of Ethereum into your PC. Okay, so I think the total space of around, if 50 GB space is free into your laptop or desktop, then type this command, and it will take a lot of time. maybe 1 day or 2 day. It depends upon the processing speed of your system, internet speed of your network. Okay, so it will download the entire blockchain, Ethereum blockchain into your PC. So you can create using this particular blockchain, create your own local private Ethereum blockchain. Okay, so you can see that nodes, is there, transactions are there, drop value is there, hash code value is there. Okay, so now it will take time. It will be for 1 day or 2 days. But after this, you are able to deploy your own private Ethereum blockchain. Without this, it's very difficult to actually implement our private Ethereum into our lab. So try it. You know? So I assume that it's yeah. So when we start our project, I assume that you all have this particular the entire blockchain into your PC. Otherwise, it will when we connect our this particular software or our smart contract with the blockchain, it will show some error that particular Genesis node is not there. Okay, so just I will close it. So using this get.ethereum.org download section, you can download the entire this particular software get.eth of 64-bit version for Windows, and then write the gph command. It will download the entire Ethereum blockchain to your PC. But ensure that at least 50 GB or 60 GB space is free. Otherwise, you can't download it. Okay. So now how we can create our own private Ethereum network into our lab or our PC. So set up our own private server to develop and deploy our smart contracts. Initialize the very first block in our blockchain. That is the Genesis node. So for this we have a file that is called the genesis.json. Okay. How we can create this file? The content of the file I will discuss later in the next slide. Now the transaction, how we can see, assume that this Genesis node is there, or the role of this Genesis blocks is there. So basically, we can assume that the Ethereum network is basically a transaction-based state machine, and with the first node is called the Genesis node. At the starting node, you can say the blend state is there, and when some transaction executed, this Genesis state transaction is converted into the some final state or the current state of the Ethereum. Okay, so like in theory of computation, we have the state machine in which we have initial state and we have certain transaction. After transaction, the state of machine will go certain state number 1, 2, 3, 4, and to the final state. So current state of the Ethereum is called the final state in that case. So basically, Ethereum is a query machine language, you can say. Now, the state of Ethereum has billions of transactions. It depends upon the miner that how many transactions he wants to include into that block. And all the transactions are grouped into the blocks. And each block is chained together with the previous block using the hash value of the previous block. So in this diagram, you can see it's very easily. Now, question is that when we create our own private Ethereum network or Ethereum blockchain, so how we can create the first node? So first node is the Genesis node. So for this, make a folder called the private chain. You can make it on desktop also. And in the desktop, you can make one more folder for the chain data that is used to store the data. And then make a file of genesis.json. I will show you. This folder is there. So make a folder of name private chain is there. Okay. Inside the private chain folder, make one more folder that is the chain data. And one more file that is called the Genesis file to see the content of this file. So this is a fixed, you can say parameters are there for Genesis node. Initially, we initialize every value is 0 because it is the first node. There is no producer node in the case of Genesis node. The Coinbase value is initially 0. difficulty level is there. What is the meaning of difficulty level? I will discuss later on. Then extra data is blank. There limit is some limit is there, and this value is 0, and mix hash value is again 0. Parent next field is 0, 0, 0 because no parent is there. Timestamp is 0. Then allocation config and these some parameters are there. We'll see that what the meaning of these parameters later on. So just copy this data into the file. It's called genesis.json file. Okay, and then we'll save it. It will automatically connect with the network and create a node that is called the Genesis node. So you just copy that code into the file and save it file here with the extension of JSON file, Genesis node file. Okay. By default, you can, when you create the file into the notepad, it will extension .txt. Please ensure that when you save it, the file, when you save the file, the file name is Genesis, but save as type, so make it all file and then put here genesis.json. Dot also should be there. Okay, the dot JSON, the save as type of all file, and then save it. Okay, so this file is there. So we have created a folder of private chain. Inside the private chain folder, we have the chain data folder with one more file that is called the genesis.json file. Now, so how we can create our Genesis node and how we can initialize our private network and store data into the data directory folder that's called the chain data. So there is a command of Ethereum. That command is this particular. Control C, copy this command. When here, open the command prompt. So how to open the command prompt here? To just shift and right click with the mouse. Click open command windows here. So you can click here because the option is not in this PC. I'm trying. We have just download the, but I think still download is there. No, we close it. So I will try to run this command, but definitely will not give the correct answer because the blockchain is not there. So it will try to connect with the blockchain, but let it will give a fatal error because it is not the blockchain is not there. But when you download the entire blockchain with the get th command, it will not be there. It will show that this is connected and it will create the Genesis node. In this PC, the blockchain is not there. That's why it creates the fatal error. Fail to write Genesis block. Okay. So, but in that case, when you have the blockchain, it will not show any error message. It will just create the Genesis block. Now, after that, when we have created the Genesis block, run the command get data directory is equal to /chain data. Okay. So again, run this command. In the same folder, open the command prompt and run this command. Okay. So it will try to connect that particular blockchain and start your private blockchain, and it will open the port number 30303, and that port number is generally used to communicate with the other you can say ID, which is generally used to write the smart contract or your code of particular node. Okay, so it will take some time, but at last it will give also error because that blockchain is not configured in this particular desktop PC. Okay, so but suppose it is there, then at last it will open the port 30303. So it is looking for the peers, looking for the header nodes. It will take some time. Okay, so leave it for certain some time period. But at last, it will show the message that it is connected and open the port number 30303. Okay, so it will open the port 30303 for the communication with the other nodes and different types of software for which we can create the node. And if you want to know more about this particular process, then you can use the ethereum.stackchain.com. you will get the more information regarding that how we can download the Ethereum blockchain, how we can create our blockchain, how we can create the Genesis file, how we can connect that Genesis node with our existing blockchain data, and how we can open the code 30303. Okay. Okay. So it is completed. It is also completed. Yeah. So when we open the port number 30303 for the communication, so for the communication, so communication means that when we deploy our own smart contract, our own node, so how we can communicate that node with the peers of other peers in our own private blockchain. So basically, our blockchain is now configured. Our blockchain is running, and that is not the open blockchain, it's our private, because that entire blockchain is in our PC, and we have configured that PC for our own private, so you cannot connect with the others which are online in a open blockchain. So in this way we can configure our own private network. Now how we can connect, how we can communicate our code, our node with that particular private network. So for that we have certain APIs are there, certain wallets and certain tools are there. So like MetaMask is there, through which we can create our Ethereum wallet, as well as the Ethereum browser is there. So through which we can code the smart contract in the Solidity, and we can run that code directly through the MetaMask. So there are many, you can see options are available, like MetaMask is there, Ethereum wallet is there, Mist is there, MIST, for opening the Get JavaScript API console. And they will enter with the Ethereum blockchain with the port number 30303, which we have opened in the last slide. Okay, so you will see the brief description about the MetaMask, Ethereum wallet, Mist, and then we try to write some code in the Mist, and we'll see that how it will happen, how it will create the node, and how smart contract will interact with the existing blockchain in our private network. So basically, the first part is the MetaMask tool is there. So MetaMask is both an Ethereum browser and a wallet also. So wallet means you can know that Paytm wallet is there. So similarly for Bitcoin and Ethereum value, we have the wallet also, and that wallet used to pay the fee or transfer the Ethereum from one user to the another user. When we use the Ethereum browser in terms of the MetaMask, so MetaMask is typically not recommended by the expert because security issues are there. You have to trust on the MetaMask that whatever information you are stored there when you create your account is safe, like other wallets are there. Okay, but in our case we will use the Mist for run the program. Okay, so through MetaMask you can interact with the develop apps and smart contracts on the web without having to download the entire blockchain or install any other software. So in that case, for learning purpose, MetaMask is good, but developing purpose is not good. So it is a site through which you can download the MetaMask, and it is, I think, only the Chrome extension is available. If you try to download its Internet Explorer version, is not available. So if you don't have Chrome into your PC, then you can download it. So first install the Chrome, then download the MetaMask extension as a Chrome extension, so you can able to run the code using the MetaMask. Second tool is there, second browser is there, that is called the Mist browser. So Mist is an electron application, meaning that it's a desktop hybrid app with a web interface as well. Okay, so if you want to read more about that Mist, it's you can go to GitHub and GitHub Ethereum /Mist/wiki, and Ethereum wallet you can download it. Then you can, when you download the Ethereum wallet, it automatically append that wallet into the Mist browser. So you can download the Ethereum wallet file from GitHub. So GitHub is there, GitHub Ethereum Meteor Devs wallet. So Ethereum wallet is basically written simply pure HTML JavaScript code. And the question is that how a simple browser can pass data and create a node, and that node become the part of the blockchain. So it's not the rule of the particular Mist browser or MetaMask browser. Basically, they use the Web 3.js, Web 3.js libraries, and these Web 3.js libraries generally manage the account and run inside the Mist browser. Okay, so Mist browser by default include the Web3.js libraries, and these libraries are responsible to manage the account for the transaction and to create the node and then add your node with the blockchain network. Now, how you can download the Mist? So initially, first you can download the Mist using this Ethereum.mist release, and after the installation of particular Mist, you can run the command get data dr equal to /chain data that show that part of particular data that where you have the data. So data we have the chain data folder which we have in the private chain folder. Okay, so run this command in the private chain folder, then it will connect automatically with the Mist web browser. So let's run this command. Let's run this command into our folder of private chain. Open this, open the command prompt here. Again, we will set an error because Mist is not installed here. Okay, so but when you have the Mist and install the Mist, then after run this command, it will connect that path from Mist to the your chain data folder. So in this way, we can install our Mist browser. So if you want to see that how it's looking, so Mist is here. So when you click on the Mist installer, it will try to connect. It will take some time. So till this slide, we have download our the entire Ethereum blockchain. Then we have create the folder in which we have the genesis.json file to create our Genesis node. Then we have one more folder that is called chain data to store our own data. And then we try to attach that the path to create the path of data from private chain folder to the that particular blockchain. And then we also run the command that connect our Mist web browser, Ethereum browser, to run the code and store data from that browser to the chain data. Okay, so it is the particular Mist. So it will try to connect with the blockchain in the network, but because we don't have the blockchain in this PC, so it will become fail. So but you can see that Mist is there. So you can create your own account, and you can see that some tools are there. Open Remix ID is there. What is the meaning of Open Remix ID? I will discuss later on. It is not there, which is the empty or when you install the Ethereum wallet also, so by default it will add the Ethereum wallet here. So here you will get the icon of the Ethereum wallet also, through which you can send and receive the Ethereum from one user to the another user. Okay, we will try to see that how we can do this if the time permits. Okay, so in this way we can download the Mist and we can attach that Mist with the our folder chain data. Now, even we can write our smart contract, the code for our own node in the Mist web browser, but it is recommended that use the Remix web browser ID, okay, to write the code. Okay, so there are several languages in which we can write the code. So, but in case of Solidity code, the Solidity code in the Remix web browser, there are several, you can say, the advantages. So first is that integrated debugger is there. Step-by-step instructions, monitoring variables, call data, call stacks, all you can do in the Remix web browser. Simply you can code in Mist also, but when you code in the Remix, it's easy to debug and to see the result which we have, and then we can combine that particular code with the Mist. Now the warning is very useful in case of unsafe code. The gas course is there. Whether functions could be constant and check for the overlapping variables names. integrated testing tools are there in case of Remix web browser, and syntax and error letting action is there. Work with the injected Web3 object and can deploy directly to the MetaMask or Mist. Directly you can transfer that code to the after the successful comparison run. You can directly deploy using the MetaMask or Mist. Okay, so how we can download the Remix web browser ID? So this link is there, remix.ethereum.org. Okay, so if you have PC, so please try to run it. So you can simply copy and paste here remix.ethereum.org. So when you run it, it will open the web interface. There is no need to download the particular Remix ID here. So it will the basically Remix ID interface where we can write the code, where we can deploy our smart contract, and we can see the output. So I will try to cover that part also, that how we can deploy our smart contract using the Remix, and then we can transfer that particular smart code directly into the MetaMask or Mist, and then we can, if that particular blockchain is there, so we can create our own node. So before we start our coding of some smart contract, let's take a brief review or brief idea regarding some concept which is useful when we create the smart contract. The types of consensus algorithm is there. So there are two types of consensus algorithm is there. There is the proof of work and proof of stake that is used for the mining purpose. I think that earlier speakers also covered this topic because it's very, very important. The proof of work is basically in computing is used to validate whether the user has put some enough efforts, such as computing power or storage, or done some work for solving the mathematical problem of a given complexity before sending the request of the node. Okay, so if somebody is using a proof of work, then after that particular work, as an incentive, he gets some value of the Bitcoin. Okay, apart from the incentive also, because somebody when validate the transaction and create the node, he get the incentive plus the fees for the making that particular node. So incentive is also there, but in the case of the proof of stake, the incentive is not there, only transaction fees is there, which they can claim as a miner. So if you see that how work is there, so go to any online SHA 256 calculator tool and try to using a random number with the test hello world. So let me show you that how it's working. What is the meaning of proof of work? So I think it is already there. No. Okay, so later on we see that how we can calculate the simply online using the SHA 256 calculator. If there you can find using the Google, and then try to write the code here, hello world. Okay, and then try to suppose hash value is there. Okay, data is there, hello world is there. Now you are required to guess the value of that random number. The knowledge is there, so you are required to find the value of the knowledge value. So suppose that hash value is there, and so hash value is private value is there. It should start from 1 0. Okay, to do the task. So you have the data, you have the function, SHA algorithm is there, you have some hash concept is there, hash value is there. Now try to get the value to which you can get the hash value, which is start from only single 0. So when you enter the number 10, okay, random number 10, then you can get the hash value starting with 0. So it will take some time. So somebody will try for value 1 with value 2 with value 3, and the person who will get first. If the number is 10, to which we can get the hash value starting from only single 0. Okay, single the first value 0. and then some number is there. So that miner is winner, and that transaction is approved, and that node is then attached with the blockchain. So these are certain mathematical cryptographical puzzles are there, which is required to solve by the miner, and then the somebody who will get first, who will get the answer, who will get the value that is the less than some threshold value, he will the winner, and he is the winner, and then the rest of the miner stop to mine, stop their work to find the value of that random number. But because they are participating in the process of validation, they also get some incentive. Okay, some minor incentive is there. Okay, so but they, after getting the incentive, they start to validate some another transaction. Okay, so it's called the proof of work. So what is the advantage of this proof of work? It's completely decentralized, achieved by it totally, because there are n number of miners are there who are distributed, who are decentralized, and they are trying to get their value, and who will get first, he will become the winner. So nodes are easy to implement, and but a huge cost and computing power required to destroy the system, and protection from the DDoS attacks, distributed denial of services, because it's totally purely decentralized approach. But the disadvantages are very important, because the wastage of energy and resources are there. Why? Because suppose hundreds of miners are working on a puzzle, and only one is winner. So rest of 99 miners are wasting there. You can see it is a waste of energy and resources, because it requires a lot of computational resources and energy. आपके सिस्टम पे चलेगा, तो your laptop is busy, your RAM is busy, your energy, your power is there. Okay, so everything is wasted if you are not the winner. So ratio of energy and resources and miners perform work on the creation of blocks that consume a lot of computing power, and only one miner will get the reward who resolve the puzzle first. For resolving the proof of work problem, miner must have a computer with a lot of processing power and electricity with other peripherals to maintain the moderate temperature, which is very expensive. And but because it's totally completely decentralized approach, so we use the power of this proof of work approach in case of Bitcoin, in case of Ethereum, in case of Litecoin, in case of Zcash. So all these cryptographies use the power of the proof of work algorithm to confirm that some node is there. Okay, to create a node, basically you can say, to validate the different types of transaction. Second up is the proof of stake. So proof of stake means it's a new type of concept where every individual can mine or even validate new blocks only based upon their coin possession. It means how much money you have into your wallet. Okay, so in this scenario, the more coins you have, the better the chance that you are winner and you can validate the particular transaction. So all the miners of the network are randomly chosen. If you have a specific amount of coins stored previously in your wallet, then you will be qualified to be a node on the network. So after being a node, you can, if you want to qualify for being a miner, you will need to deposit a certain amount of coins. After that, there will be a voting system for choosing the validator. When it's all done, the miner will stake the minimum amount required for the special wallet staking. And the approach is very good because the approach is energy efficiency, because only one is a miner, and we are choosing by voting system. Who will as a node, who will validate the transaction using the voting system, but requirement is the money. How much money you have into your wallet system. And the proof of stake basically algorithm energy efficient, especially when compared with the energy requirement for the proof of work. And security is also there, because suppose some attacker is there, so if you want to participate into the POS system, then he also put their assets in the wallet. Okay, so there are two advantages, but generally most of the particular cryptocurrencies are using only the proof of work. Other consensus algorithms are also there, like proof of elapsed time is there, proof of deposit is there, proof of capacity is there. But mostly, if you see the algorithms or cryptocurrencies are there. So only POS and POW is famous. These are not especially used by the popular applications, but you can use. You can read the concept of proof of elapse and proof of deposit and proof of capacity also. But these are not in the market, not popular. So everybody is not using these three algorithms. Now come on the main point that how we can create the smart contract. So to create the smart contract, basically, let's see that what is the meaning of the smart contract in case of the blockchain. So suppose two parties are there and they sign some contract based upon their requirement and no third party is required. And when certain condition is matched, then automatically this contract executed. That is called the smart contract. For example, suppose earlier days we had a scheme from Domino's Pizza, okay, or Pizza Hut, that if you order the pizza and the pizza is not delivered within half an hour, then the entire pizza cost is free. Okay, you will get the pizza free of cost if it is not delivered within the half an hour of the order time. So by default, what is happening that when somebody is issuing the order, so it will store into the node and it will check the condition that if the order time and the distance of order time in the deliver time is more than half an hour, so automatically it will cut some money from the Domino's Pizza wallet and transfer into the wallet of the customer. Automatically, there is no third party involved, and when all the nodes running on the particular blockchain give the same result, yes, it is delayed by more than half an hour, so they will confirm and they will transfer the amount from the company wallet to the customer wallet. There are many more examples, like somebody is there and if there is some delay in the airline, say more than 2 hours, then automatically some incentive is there which is cut from the company wallet automatically and it will transfer to the passenger wallet if the flight is delayed more than 2 hours. Okay, so there are a lot of examples there where you can use the smart contract. It is useful when we work with the signature, with the authentication process. It is not good for the complex process like emails is there. Okay, so when you want to develop a small project, small validation process, you know, like in Purnima last year we developed a certificate which you can validate. Suppose I issued a certificate to a student that he scored first position into the game or chess or in the class BTech second semester. Okay, so if somebody is there who want to confirm that this certificate is original or not, so some barcode is there, and then they will use that particular software or the blockchain. It will confirm that this particular certificate is original and issued by certain authority. So you can use that particular project using the smart contract. So how we can deploy it? Let's see. So terms and conditions are defined previously when we write the smart contract. The terms and conditions of an agreement is written in the code, and each agreement facilitates the exchange of money, shares, property, whatever the condition is there. Okay, and it executes in blockchain's decentralized platform like Ethereum is there. Okay, so how we can write the smart contract? Let's see. So what is the process to write the smart contract? To create a new contract account, we first declare that address of new account using a special formula. The formula is not written by you, but we assume that whenever we use the MetaMask is there, Mesh is there, so you can use that facility to create your own account. Okay, like if we see this Mesh, so you can create your account here. New account is there in the file menu. Okay, so in this way we can create our own account. There are many platforms online is available where you can create your account. So initialize the new account by setting this Gnosis to 0. If the sender sends some amount to the of Ether as value with the transaction, setting the account balance to that value, then deducting that value added to the new account balance from the sender balance. Okay, setting the storage as empty. Setting the contract code hash as the hash of an empty string, as we have seen earlier. Then we have actually created the account using the init code sent with the transaction. So init code is basically used to initialize the certain values of a transaction. Now, depending on the constructor of the contract, it might update the account storage, update the create other contact accounts, make other message call. As the code to initialize the contract is executed, it uses gas. So gas क्या है? Gas is basically the cost of the particular transaction which we have paid to the miner in terms of Ethereum or Bitcoin. So fees basically you can say. So it is not allowed to use more gas than the remaining gas. Suppose we have 100 gas in our account, so you cannot use 120 gas for the transaction. It is not allowed. Okay. If it does, then execution will hit an out of gas OOG exception and then it exit. And the transaction exit, then the state is reverted to the fund immediately prior to the transaction. So whatever you have cut money from your wallet, it will again redeposit into the account. Okay. So sender not refunded the gas that was spent before the running out. Now, if the sender sent any ether value with the transaction, so ether value will be refunded even if the contract creation fails. If the initialization code executes successfully, the final contract creation cost is paid in terms of gas, the storage code, and is proportional to the size of the created contract code. If there is not enough gas remaining to pay this final cost, then transaction again declared and out of gas exception and abort. And all the transaction will again in the previous state of the starting of the transaction. So we can understand this using some process diagram also, that every computation that occurs as a result of a transaction incurs a fee that is called the gas. So in this case, the gas limit is 50,000, the gas price is 20 GWE. That is the unit for the gas when we pay through a transaction the Ethereum. And the value of this gas I think that we have discussed that in case of Bitcoin, we have the Satoshi. And in case of Ethereum, we have the this GWEI. Okay. Now, sorry, WEI. Or when we pay this particular WEI using the for the gas, that's called GWEI. That is the tangible about 9 V. Now, the sender suppose want to start some transaction, then it will cut the 50 gas as a charge. Okay. So in the initially wallet, they have the 250 gas. It will cut the 50. The remaining value is 200. Again, suppose second operation, it will cut the 30 gas, and remaining part is 170. It's end transaction. The remaining gas value is 170. It update to the particular account of the sender. So sender now has the 170 gas value in the wallet, and then the transaction will send to the receiver. Okay, it is a basically successful transaction. In case of failure case, the sender suppose initially has 250 gas. It start the transaction. To start transaction, then it will use the gas again, depend upon value of transaction, the type of transaction, the size of transaction. Okay, according that will decide the gas value. And suppose during the transaction, the gas value is 0 in the wallet. Okay, so it will revert, it becomes failure, and it will revert the entire state. And again, initially the sender again has the 250 gas value, and it will not, any transaction will not send to the particular receiver. It reverts entire state of the node. How we can take the fee? So sender we have initially start a transaction. Is miner is there, because miner is there who will charge for the validate transaction and create the node. Okay, so operation 1 is there. So we cut the 50 gas, depending upon the miner choice. Okay, for second operation, it will cut the 30 gas value, and it will deposit it into the miner wallet. And then after the end transaction, the remaining values of gas it will store in the sender, and transaction node will send to the receiver. So in this way, the miner is getting the incentive. Okay, so it will charge the transaction fees, you can say. So miner has the two types of income. One is called the transaction fees, that is incomes of gas. Second is called the incentive, that is if that miner node is selected. If the miner is basically actual miner that validate particular transaction. Okay, so that is based upon the who will solve that mathematical puzzle or cryptographical puzzle. that is the winner. So that incentive is there, and this transaction charges is also there. So in this way, they are earning because they are mining, they are trying to validate your transaction. Okay, but in the case of proof of stake, there is no incentive for validate the transaction because that process is not there. Based upon your valid account, the voting through the voting process, they will select that who is the miner for that particular node. So that's why we are not getting the incentive, but we are getting the transaction fees in terms of gains. Now, the second requirement is with the EVM. EVM is the Ethereum virtual machine, which is used to execute the compile the particular bytecode of the smart contract. It is like simply as we have the Java virtual machine in terms of bytecode. Okay, so EVM also has the storage. Unlike memory, the storage is the non-volatile memory. EVM store the program code separately in a virtual machine in a virtual ROM that can only be accessed via special instruction. Differ from the one-level architecture. Code is written in the high-level language such as Solidity compared to the EVM bytecode that the EVM can understand. This is a figure of the EVM machine. You can say Ethereum virtual machine. The code and storage both are different part. Here in the storage we have stored the code, and here we storage is there. Okay, for the instruction. Then stack is there, so we have to specify stacks size in case of EVM. Okay, these are arguments is there, some memory part is there. Okay, now when we write the smart contract into the for the purpose of Ethereum blockchain, so how you can write the smart contract? So there are three popular languages are there in which you can write the smart contract. One is Solidity, second is called Serpent, and third is called the Tipple, that is the Lisp-like language. So Lisp-like language and Serpent is not so popular as compared to the Solidity because Solidity is simple as we have the syntax in JavaScript and C++. So it's more popular in 80 or mostly in case of if you see the development in the blockchain, so they all code in the into the Solidity programming language. So it's a simple because the most of the biggest plus point is that it is same as the JavaScript. If somebody knows the simple JavaScript, so they can easily understand the concept of the Solidity and they can write the smart contract within the Solidity. So designed to compile the code for the Ethereum virtual machine, and same types are here, like Boolean is there. Boolean is for the bool variable. It supports the logical negation, logical and operation, logical or operation, equal to operation, not equal to operation, as we have in C, C++, Java. It supports the integer type. So generally we use the int 8 and int 256 and u int 256. So u int 256 unsigned integer 256. So 256 bit is there because the size of Ethereum is 256 bit. So to support that EVM, we use the u in 256 integer type when we write the smart contract. We also support these less than, greater than, not equal to, the comparison operators are there. It also supports the bitwise operator like AND or bitwise exclusive and bitwise or in negation. It also supports the shift operator, left shift, right shift. Okay, the right shift divide karna and the left multiply by 2. Also support the all arithmetic operation plus, minus, unary, star, multiplication, division, power, as we have in JavaScript and Java. So basically in case of contract, the certain address variables are also there because sometimes we are required to validate or deploy that particular contract on a particular address. So how we can hold the address? It holds the address of a node using a 20 bytes value. That is the size of an Ethereum address. So there are two types of address. One is called simple address, its own address, and address payable. It means you can send Ether or to you can send Ether to this particular address. Okay. So it is the sender address, simple address is there, and then address payable means who is the receiver. Okay. So when you perform the transaction using some smart contract, it will cut the money from the address here and it will deposit of the address node which is here. Okay, address payable. Every contract defines its own type. And every contract can be explicitly converted to and from the address type similar to the class, because why it's there, because suppose some transaction fails, so whatever transaction is there, it will revert back. So we can explicitly convert it to and fro from the address type. Similar to the classes in the object oriented language, we use the contract. Okay, we try to develop some contract here. We have 20 minutes more. So they contain the persistent data and state variable and function that can modify these variables. So variables are, in the case of Solidity, is called the state variables because they represent the state of the EVM. Okay, and the function, it can modify these variables. So we have three types of functions for Solidity. One is called pure function, one is called view function. Let's see how we can define the function. So function is there, the function keyword is there, the parameter type, that concern integer is there, or some boolean variables are there. Okay, then we have the public or private keyword. Then we have three types of function: pure function, view function, and then payable function. And then we have to mention also that if the function returns something, so what value is returned, so then types should be mentioned here. Okay, so if the function type is not returning anything, then you can remove the particular the part of return here. It's simply you can use the function and syntax value. So visibility has to be specified explicitly for the function defined in contract. The value of external function type can be explicitly converted to the address, resulting in the address of the contract to the function. Okay. So I assume that everybody know about the JavaScript and they know simple syntax of the Java. So let's try to run a particular smart contract using the remix. Okay, the smart contract, the objective of the program is that it will perform all arithmetic operations like addition is there, subtraction is there, multiplication is there, divide is there, and the mod operation is there. Okay, so how we can use it? See, simply okay, let's see, then we will try. Two more programs are there. So simple program is this last program. Yeah. So just copy it and open the remix ID. Yeah. So it is an interface where you can write the smart contract for the Ethereum purpose. So here, feature plugin is there. So you can see that Solidity is there, pipeline is there, Matrix there, security, Shortify is there, debugger option is there. So click on this particular Solidity option. Okay. So here we have the particular I think some files are already there. Yeah. So we have a file that is called the storage.sol. .sol means already file is there. So you can write the entire code here. Okay. And after the writing the code, see some syntax of the code is the program Solidity. The keyword is there. It is everywhere in the program. Whenever you try to smart contract, the first line is program Solidity. Then caret sign is there. 0.4.16. So basically 0.4.16 is the version of the compiler. Okay. So it will not support the compiler which is previous version of 0.4.16. Okay. And even it will not supported by the compiler which is more than 0.4 version. It means suppose some version is there 0.5.2, so it will not support it. But the program, we cannot run this program in the higher version also. The condition is there using this caret. So caret means and. And means the higher version is also not allowed. If you remove this particular caret, it means it will not supported by the previous version of 0.4.16 like 0.3, 0.2, 0.1. But it is supported by 0.4 and higher version. But when we use the caret also, it means it will not supported by the higher version also. So you require the version 0.4 only. Now the contract. The first keyword is the contract. Like it's the class. We have mentioned that whenever we write the contract, it's just like a class of Java. So the keyword is the contract. and then name of the particular concept. So I have written the name of concept is my hello world. Okay, now define the variables. So you can define the unsigned integer variable, you can define the boolean variable, you can define the int variable. Okay, so here I have written the unsigned integer 256 because EVM supported 256 size. Okay, the counter is variable name. Okay, so counter is variable and initially the value of counter value is 5. Okay, so these counter is called the state variable as we assign in the particular context. And initially we have written that the value of counter is 5. Then we have to a function. Okay, so function name, function keyword is there. Then function name. So function name is add, open and close bracket because no argument is there. Then write the public, private, pure, view. Okay, so this particular function is public. Open the curly bracket. Okay, now increment particular counter. So counter plus plus. So when we call the function add, it will increase the value of the counter by 1. Okay, close the function. Like the next function, function subtract. Okay, so when we use the subtract function, it will decrease the value of counter by 1. Okay, now again the third function, function get counter. It means it will get the value of the particular counter. Here we require to return particular value of the counter. So that's why we return the public. Okay, then constant return new in 256, the type of value which is returned from the function get counter is the unsigned integer 56, and the value which I want to return is counter. So return counter simply same code we have in Java or JavaScript. Okay, so once you write that code, okay, so simply telling that everybody is comfortable with the code that how we can write the smart concept. So simply just send the program. The version is there. Then define the class. Class name is there. Unsigned integer, signed integer, boolean variables, and other variables types are there. Use the counter. Counter the variable. You can take x, y, z. There is no problem. And then we have to define the function. The function is like we have the two function. Okay, and the types is there, and the role is there. The counter will increase the value. We decrease the value of counter and then return the counter value. Okay. Now run it. So before run it, we need to compile. So first, if you see the that particular area left side of this particular remix ID, the first value is the file explorer, how many files we have. Second option is the compilation successfully. So again, recompile this. So when you click it, it will show the option of compile storage. Okay. So before you compile, see some options there. So compiler version is there. Na? So it's here. So you can see lot of compiler version are there. It's 0.5.8 plus commit itna and so on. But by default, because we have taken the 0.4.16, so that's why automatically it select the version of compiler that is 0.4.16. You can take any compiler. There is no problem. Okay. Now the language, basically we have the language Solidity. Then we have the AVM version. The compiler default version we have taken. But we have taken the different type of EVM version like Istanbul is there, like Petersburg is there, like Byzantine is there, like Superior Dragon is there. So there are a lot of EVM version is there because the open source, everybody can deploy, everybody can use and publish their own version if it is correctly created. Then the autocompile action is where autocompile means when you write some lines, okay? When you change some line, it will automatically compile and see. It will show the error message is this is some error message there. You cannot use it. We will try to use the autocompile option also. And number optimization and hide warning. Warning is also there when you compile it. So let's compile the program. So I think there is no problem. But if suppose I have one curly bracket there, okay? So it will show that one. Even I did not click on the compile button here, but because auto compile option is enabled, that's why when we have a certain error, so it will show that immediately that one compilation error is there and line number 11. Okay, it's showing that on line number 11 there is some error. Okay, if you down this drop down, तो browser one storage dot इतना expected program directory content इतना function subtract error is there. Okay, so check it, and just when you remove it, okay, so line number 10 is there, just remove it, auto comparison is there. It means automatically you have removed a particular errors. Okay, so this comparison successfully. Then second is the deploy in run transaction, and third is the solidity static analysis. Okay, now see the first was the file explode, second is the compilation. So when we click here, compilation, compare it, no error is there. Now second is the deploy and run transaction. So click here, you will see certain parameters are there. So one parameter is the JavaScript environment. So which environment we are using. So you can change it. You can choose the Web3 provider. You can inject Web3, and you can choose the JavaScript virtual machine. So mostly, in most of the cases, we use the JavaScript virtual machine. Account address is there because we require some account. Okay, so by default, because it's a personal, you can say private, immediately initially, all account has the 100 Ether for the R&D work. Okay, so you can change any other account also. So each account has initially 100 Ether deposited by the Remix IDE. Okay, you can copy the value of this account also for some coding purpose. Okay, so when you want to subtract or you want to deposit some amount of Ether into the account, then you require the value of this account. Gas limit is there. That maximum gas is there in the account is 30 lakh. I think 3 lakhs. 30 lakhs gas limit is there. You can increase and decrease for the particular project. Okay, the value is 0 for the transaction fees. I am saying that the 0, I will pay 0 Ether for the particular transaction. Okay, it's totally free transaction. Now the contract is there. Hello world browser 1. Now deploy it. So press on deploy. Okay. See here, the bottom right part here, it will compile. Creation of hello world is pending. Now I think it is clear. So now when we click here or the debug part, down combo box is there. So when you press the combo, this down list, you will see that status is few transaction mine and education success. Transaction hash value kitni aayi? This is show the transaction hash value. Contract address. The address of this contract is like this. Here you can use for the certain other operation. Now from the account address is there to the receiver address is there. Hello world constructed is there. The gas limit is 30 lakhs. Gas limit is there. Transaction cost of this transaction is I think 1,39,409 gas they are charging for this particular transaction. Now education course is 70,101 gas. Hash value is this. Input value is this. Decode input is this. Logos is this. Value is this. Okay. So so many parameters are there depend upon the environment through which you want to deploy your contract. Now when you deploy the contract, to see what is the actual output. So we have you click here. The contract is the hello world. Hello world address is 0xd. This is the hexadecimal number address for I think. And when you click here, okay, so you will see that we have the 3 boxes are there. One option is add, one option is subtract, one option is get contract. Means successfully you have deployed your particular contract. Okay, so when you will add, so suppose I want to get the counter, so click here get counter because function return something. So it will return the unsigned integer 5. Okay, so 5 is there because initial value is 5. When you press on add, it means some transaction is there. It will add some +1 to the counter value. Okay, so now see the value of the counter variable. It will become 6. Okay, now next transaction is subtract. So suppose I click on subtract. Okay, now check the value. It's again 5. Subtract. Again check the value. It becomes 4. Subtract again. Check the value. It becomes 3. Okay. Similarly, suppose somebody want to transaction for say 4 times, na add transaction is there. So 1, 2, 3, 4. So 4 times I press add option is there. So now get the value of get variable counter. So it becomes 7. So 3 plus 4 is 7. So in this way you can write your smart contract. You can define your transaction. It may add, it may delete, it may anything. Okay, so there are lot of operations are there. So this you can perform your transaction. You can check your particular transaction within the this Remix web ID. Okay, it's simple, and I think that options are clear to everybody. You know, these are certain options are there. More options are there, like bigger options there. You want to check that line by line. I want to debug where is the error. So you can start debugging. More options are there. Suppose you want to run again all. Suppose that we have only one program is there, storage dot storage. One more program is there. One more program is there. So you want to run the whole programs at a single time. So you can run the all operations, all already programs are there. Okay, and these are the particular contract fetches. You can fetch the contract address and load into the some editors like Ethereum is there, Rinky is there, Coven is there. These are certain settings are there which module are the active and which module are deactive. So these are currently active. You can deactive also, and certain are still active. You want to deactive or active. Do you want to show here on the toolbar? So you can do this active and deactive. Some settings are there which is not required if you are beginner in the case of Solidity. So I think that this option is only 3 options are required. One is compilation, second is run and deploy, and third is that how many warnings are there. So first compile it. Okay, compile. If there is no error, deploy it. Press on deploy. It will create the contract here. Okay, so name is here. Okay, so name is here. Click here. So second time I deploy it, so it means 2 contracts are there. If the previous contract is there, if the new one contract is there. So click here to show that how it's working. So these are the different transactions. Okay, 5, subtract, and so on. So in this way, you can add many, you can say options are there. Read the entire syntax of the different functions in the Solidity. It's very simple. You can find many documents are there in which you can find out how many variables are there, how many functions are there. Only you can see loops are there, if conditions also there in case of particular Solidity. So when we run it, so let we have 5 minutes more. So like how we can check that big number is which number is big and which number is small in the conditional operator. So simple function we make it simple arithmetic and name of the function with 2 arguments, unsigned integer a, unsigned integer b. Then pure function b. Pure means that it will not change to modify the value of the state variable. Okay, so in that program when we return it, so it will not change the value of a, the unsigned integer a and unsigned integer b. That's why the function is called the pure function. Okay, so that the name of return value is unsigned integer o, and return value is a greater than b. Then the conditional operator is there. If a is greater than b, then definitely return with a, and otherwise return the value b. Okay. So if you want to check the 3 numbers, you can again use the same code a greater than b, a greater than c, then return a, otherwise c. If b greater than c, or return b, either c. Okay, so there are many programs in Solidity which are simply as we have program in Java. So you have to see that how many functions we can create, how many types of transactions we can make, even how we can define the transaction from one address to the another address, in which we can add some money into the wallet, and then we can deploy this code for particular smart template to the NIST. We have done this particular only compilation purpose, run purpose, deploy purpose only, and in case of Remix, but try to deploy this code into the NIST web browser, then NIST will connect this with the your private blockchain. Okay, then using the function start miner and close miner, you can see that how the mining is there and how the balance of your wallet is increasing or decreasing. Okay, it requires one more session to show that how we can merge this particular code with the mist and the mist with the particular Ethereum wallet with the blockchain, which we have downloaded from the particular Ethereum site. Okay, so I think it is. I finish it. If you have any question, you can ask me, or even you can mail me. I will try to give answer within the time period. So my email address is you can mail me on dean.sce@punima.edu.in. Okay, so it is my email address. If you have any query, so you can send me the query in this using this email ID dean.sc@punima.edu.in. So I will try to reply within the time. And if you want some more code, some more simple project, some simple project for the student of BTech first semester or BTech second semester, so I will help you. I will send you a list of the projects which in first semester they can deploy using this Solidity, and they can make small projects like we have in case of certification validation. We apply this for the character certificates. Okay, so you can validate that certificates using the barcode that this certificate is validate. Original certificate issued by the Punima. Okay, using the blockchain. So there are a lot of projects which you can make in your department. You can start some research work also in this area. So I think it's sufficient for today. 12 o'clock. I finished within the time period. Thank you. If you have a small question, then please ask me. Otherwise, I will mail you.
Thank you, sir. Thank you so much. Thank you for sharing valuable insights with us. Sir, there are some questions in the chat section. Shall I read it for you?
Ma'am, it's better that you mail me because I have a meeting with the president, sir. I schedule it at 12 o'clock. So I will mail I will mail you entire answer of the set of the question to you, and you can then send back to the participants.
Okay,
so
sir.
Where I can see the questions?
In the chat section, sir. So one participant has asked about explaining minors.
Ma'am, so mail me all the questions, and I will mail the answer of the all questions to you. Then you can send back to the participant. Okay.
Okay, sir. Thank you, sir.
It's not visible to me. I have certain message where the question is not there.
Okay, sir.
Not audible, not audible. Can you give some research resources of blockchain? So yes, I can give you. I can mail you some list of the projects which we are running here in the Punima, and then for the first year students, for the second year students, how we can create the smart contract, how we can create the certificates, which we are implementing in Punima, how we can issue even the mark sheet also. Suppose some mark sheet is there, so it's very difficult for the government also how to validate that mark sheet. Suppose you want to join the government job, the government authority send an email or some letter to the college or university that please confirm that this mark sheet is original or the marks which we have is original. So we can use it using the blockchain. So using blockchain, they can validate immediately. So how we can do this? I can guide you. We have the particular project also in Punima. So if you give me your email ID, then I will send you the entire concept of this particular project. Okay, ma'am. Thank you, Priyanka.
Okay. Thank you, sir.
Okay.
Thank you so much.
You can mail me. I will reply.
Okay, sir. So now, thank you to all the participants also. Now we are having lunch break till 12:30, and 12:30 again we will gather here for the next session. Thank you so much.
One more simple question is there that you the knowledge is there the random number. So basically, say random number, and we have an algorithm that do the that random number. Okay, so that final like if you have the name of difficulty, because when we increase the incentive, suppose because we have the limited number of bitcoins or Ethereum. So when we suppose the mining is very you can say increasing, so when Bitcoin generation is very high, then automatically the algorithm decrease the number of you can say the incentive and increase the difficulty level so that you can get the incentive very you can say after a lot of time or great effort should be there, and how we can define the difficulty level that depend upon how we can use the this knowledge number as a random number. So some conditions are there, some algorithms are there which produce that number. So I will you can find out which algorithm using Google, or next time I will mail you the entire algorithm. Okay, ma'am. Thank you. I
Okay,
think
thank
no
you,
other
sir.
questions are there.
Yes, sir. Thank you so much, sir.
Okay, thank
12:30
you.
again. We will gather here for the next session. Thank you so much.
Thank you, ma'am.